Good morning, everyone, and thanks for attending today's webinar on the top overlooked weld cable risks that apply in the field. We have some great presenters today to bring you some knowledge about the Amphenol TPC observations in welding cable, as well as some potential solutions that can be deployed to make your operations more streamlined. First, just a brief summary if you're not familiar with Amphenol TPC wire and cable. We are a 46-year-old wire and cable manufacturer based in the Cleveland, Ohio area with a global reach as part of the Amphenol Corporation. We specialize in wire and cable solutions for harsh environments, all different types of applications, whether that be flexing, abrasion, impact, high temperatures, or exposures to different chemicals and contaminants. The core markets that we serve and applications are all the harshest manufacturing environments that you find globally, such as automotive plants, different types of manufacturing facilities, vertically integrated steel mills and machining centers, mining operations, refineries, as well as shipyard and marine fabrication and port operations. If you're not familiar with the Amphenol Corporation, TPC is one of the 140 business units within Amphenol, a publicly traded company on the United States New York Stock Exchange. Just under 100,000 employees globally. We operate and have locations in over 40 countries, offering solutions in everything from connectors, wiring cable, sensors, antennas, etc., in major industries such as automotive, industrial, aerospace, and defense. We're one of their 140 business units, again, located in Cleveland, Ohio, in the United States. For today's webinar presentation, just a few highlights of what our presenters will cover. The three most common risks that they see in the field for welding cable, some of the causes of that failure and the impact of those failures at a work site, some mitigation and improvement strategies to make your operations more safe and streamlined, then a little bit of talk about solutions that can help those mitigate those risks and increase efficiency and improve your operations. And then we'll take a few questions here at the end for anyone that has it. And I'd like to introduce the two speakers in today's webinar. And Paul, I'll let you take it from here.
Yeah, hi, good morning. I'm Paul Secco. I am the Key Account Manager in the Marine segment market. I have roughly 10 years of experience in the welding industry prior to coming to Amphenol TPC. So I'm pretty familiar with a lot of the issues that we're going to talk about today, and look forward to helping you guys out.
Hi, Eddie Siebold, Product Manager here at Amphenol TPC. I've been with the company for just over 2 years now. Managed the portable cord power cable lines, as well as, of course, the welding cable and various other products, mostly in the rubber material category. I've experienced, most of my experience has been in the product management field, even prior to my role here, as well as new product development. So, taking new ideas, idea generation all the way to launch. That's another big piece of job here, making sure it's high quality product and high performance. Thanks for joining us this morning.
All right, thank you, Eddie. All right, we're going to transition here into the common weld cable applications and their risks.
So weld cable shrink back, just to kind of give you a 30,000 foot view, is when the cable heats up, you're probably aware, like in the lug area, when the cable heats up, the jacketing will start to shrink away from the lugs or from the cam lock, where you'll start seeing exposed copper. So that is due to excessive heat and the jacketing breaking down. So it's known as shrink back or shrinkage, and that's really a a big issue in a lot of weld facilities that most people just kind of overlook because of safety, and also it lowers the performance of the welding machines. So some of the things that causes it, like I mentioned, is high heat. Really, a lot of current running through the cable, poor connections. Basically, the cam lock's not fully seated, or the lug's not locked down. Then also, environmental conditions with cables coiled up and not fully laid out while welding. Those can cause that overheating, which is really the primary factor.
Yeah, to jump in on the product side. So if another thing is just like anything, making sure that you're choosing the right products. There's a ton of different options out there today in the market, different materials, different mechanical properties. There's the standards, and then there's some that fit certain applications better. So just be cognizant of choosing the materials. The product that is designed for that application is very, very important, especially with thermal contraction. So inappropriate material selection, that could be a huge leading cause of the shrink back issue. And we'll touch on this in some slides coming up, but if you're using the wrong material, it's just going to speed up that shrink back process, and it's going to be really evident. The type of insulation material used in the cable plays a huge role. Certain types of rubbers, plastics, alloys, making sure you're using the right copper stranding. These are all some of the product factors that come into play and can cause shrink back if you're not selecting the right ones.
So, we talked about shrink back and how to identify it. This is kind of, if you notice the pictures here and the little videos, that the exposed copper, that's pretty much the real visual indicator, right? You'll see the lug or the cam lock, and you'll see copper pulling away from that, and then cable. And a lot of times in there, you'll see the copper will become black in some areas where it has been burnt due to that overheating. You'll also see some of the loose insulation. Maybe the jacket itself will have some cracking or some burn marks. Those are sort of the things that you'll see as visible indicators of that.
So I touched on this a little bit on my last couple slides ago, but again, harping on choosing the right materials, super, super important here. There are materials that are less prone to shrink back, and thermal expansion coefficient is something to look at. Cables do come with ratings. So selecting materials with low thermal expansion coefficients will reduce that shrink back effect. And for example, CPEs, EPDMs, just to name a few, XLPEs, which is cross-linked polyethylene. These mostly fall into the thermoset category, which tend to have the lower thermal expansion coefficient. And just making sure that you're looking for those. So CPEs, EPDMs, XLPEs. Our Amphenol TPC product is a CPE, so it's a thermoset elastomer. Another thing is compatibility. Ensure you have the right compatibility between all the components of the cable, not just the jacket, but making sure that everything is working together. Some come with fabric separators and serves, and there's different materials within that subcategory as well. There's nylon, mylar. Some don't have any separators at all. We use a fabric serve, which is a little bit unique, but that also helps. The design helps improve it helps mitigate the shrink back effect significantly. So yeah, mismatched materials can definitely exacerbate the shrink back issues. So just something to look out for.
So some of the things that are concerning, with the shrink back, some of the ways to help stop that, I think Eddie talked about as far as the materials. There's also using some controlled cooling as far as reducing that thermal stress, taking the temperatures down slowly. That helps maintain some of that stability of the weld itself. But for the cables, it's this is to be clear, we're moving in more now to the production side where you're removing the stresses from the actual weld joints themselves. The cables are critical to that as far as keeping them from stressing heat and from, excuse me. The cables are critical to eliminating heat spread throughout the weld joints. The more they are wrapped and coiled, the more those create a problem. The heat and shrink back as well. The overheating from that coil will cause it to shrink back faster. So spreading those cables out, helping eliminate some of the stresses by cooling the materials, post-weld heat treatments to relieve the tension. Those are all things to help minimize mechanical stresses, right? So being aware of all of that while welding is really critical, as well as doing control or checks to identify those issues as well, to help keep shrink back from approaching. The common risks, application risks for crushing, impact, and abrasion. Right here's an image of some crush as well as impact. You see the cable split. That's caused by various things, forklift, being run over by the forklift or actually forked with the forklift, dragging materials across it. That in itself is a huge safety concern, right? That will cause arc strikes and potential fire hazards. Part of the reason for that is the weakening of the jacket.
Yeah, some other good images to show what that might look like in the field for any type of crush impact. With some of the things to look out for, so harder, brittle texture in the crushed region. I think of that picture right up top left is a good one to represent that. As you can see, there's the jacket. There's been a clear point of impact, and it looks like it's penetrating all the way to the conductor. Another thing to look out for is reduced flexibility at the point of damage. This could be caused to the conductors falling out of its lay, and you can it'll stiffen up at that point. And it's usually you got to touch and feel the cable, but usually you can find that spot with the reduced flexibility. I recommend laying the cable that might be suspect out flat on a flat surface, and usually you can see that section of where it doesn't have the flexibility properties that it originally had. And another one to look out for is just conductor strands may appear broken or compacted if cut open. So if you do see an area that looks a little off, or you may have seen the two I just touched on, and if you don't need to use this cable, it's best practice to cut it open and inspect the strands for any breakage or compacted copper. Some of the risks and dangers from this is obviously electrical safety hazards. So crush cables are one of the leading causes of shorts, shocks, and fires. Durability, so that, again, it weakens the cable's original performance and construction integrity, leading to future failures. And then operational risks, so it disrupts workflows, it's downtime, which, as we all know, is dollars. So these are just some things to look out for, and important risks and dangers that come along with this stuff.
So, some of the ways to help protect the cables from that kind of damage is if possible, keeping them off the ground. I know it's not easy, but some places use cable trees to lift them up and clear walkways and paths. They also have channel guide protectors, right? I call them like speed bumps in a work environment. The cable sits in it. They're either plastic or steel, but they keep them from being run over, and they kind of store them away. So if you can't get them out of the pathway, that's one way to make sure they stay safe. And then of course avoiding sharp edges. That's should go without saying, but unfortunately sometimes that we still have to say it because most guys don't really pay attention because it's not their product, right? It's not their material. They're just using somebody's at the workspace, and they don't really care. But the cost of replacing cables over time is just exorbitant. So those are some of the main ways to keep and prevent cables from getting that kind of damage.
Yeah, as far as going back to the product selection, to help mitigate these these point of failures and the abrasion and crushing, one of the obvious ones, it might be a little bit more obvious just because I deal with this all the time, but it's opt for cable with a thicker jacket, especially in the thermoset elastomer, and we're talking rubber product. The thicker, you're going to have more of that shock absorption. It's going to be less prone to tear or cut, or sometimes we call it chunking, where a commodity cable or a lower grade material in the jacket, you can actually see just from over time being dragged or moved, just the activity, you will see chunks of the jacket in little small areas just basically fall off. So that's something that's really important. That's why I put a star there, is just really look for the thicker jacket. And then importance of flexibility and flex life. This goes back to selecting the right materials. So the flexibility gives it more agility. You can move it to areas where a cable that doesn't have those properties might not work. So something to think about. And then just proper materials. Again, looking for those the materials that are designed for that abuse, which is why we like the thermoset elastomer, because it really holds up to a lot of these variables. Next slide. So this is a good image on the right showing two different cables. The one on the right is the Amphenol TPC 600 volt Weld cable. So that's our cable. And then this is just a commodity cable in the black on the left. And you can see it's just right away a noticeable difference in that thickness, that jacket thickness, overall thickness. So again, it's going to give you abrasion and cut resistance, longer lifespan, less downtime, and then everything else that goes along with that. So it's better as a safety precaution, and cost efficiency. So if you look at the overall cost of ownership, you're going to have fewer replacements, lower maintenance costs over time.
So application risk from cable overheating. Here's a good example of a cam lock that's burnt to a crisp, right? So they primarily due to excessive current. Pretty simple. Poor connections, which damage insulation, and proper cable for the job. Undersized weld cable, or not properly rolling it out too long of weld cable for too high of an amperage. Those are all things that can help cause that overheating. Next.
So how do we identify overheated cable? Something to look for is it's just discoloration. So just burn marks, charring areas, overall fading of the cable jacket. That could be a leading indicator. Any melting or odor that is usually, not recognizable. If you do start picking up on that might be another it might be leading to overheating, and then risks and dangers involved, fire hazards, of course. So the cable can actually ignite, and also spread to nearby materials. So huge safety factor there. And then the insulation damage. So, when you're working with this super high heat and excessive heat in this case, it really does degrade the insulation, exposing conductors and copper. And this is another safety risk, increasing the risk for shock. And then the equipment. So this could, the overheating of the cable can lead to other equipment being damaged, or needing to be maintained or repaired, which again is downtime, power inconsistencies, overall reducing performance. Some of the things to build off the last slide, inspect the cable before use. Make sure, I think Paul mentioned this earlier, but secure connections is very important. And then cable management, so doing all the best practices, making sure uncoiled, properly sized for the job. And as far as the product goes, choose the correct cable size. This is sometimes overlooked. So selecting a welding cable with the right gauge size for the intended current load to minimize the resistance and heat buildup. This is a really important step to avoid the overheating. And then high quality insulation materials. Again, there's a lot of materials out there. Making sure that you're, it might come with a premium price point, but in the long run, that total cost of ownership, choosing the high quality materials are going to benefit. And then plan for proper installation. So adequate ventilation is very important. Avoid tight bends, bends that exceed the bend radius of the cable. So make sure you're paying attention to that. And maintain secure connections, again, is super, super important.
So welding applications. So as you can see, not all is created equal. I think Eddie really gave a good example or explanation on our cable and the jacket itself. So, one of the things to give an idea is, or some anecdotal evidence is, we have a customer that switched over for some of that black commodity cable that was in the picture showing side by side. And over the course of 4 years, saved roughly $1 million in just cable usage because ours is lasting so much longer. So I think that's a pretty good indication on the longevity of our cable and the ability that it lasts. But there's it beats replacing it all the time. And that's kind of what they've got to where they're at now. And they really appreciate that service that we've provided to them and the partnership.
Yeah, and I do want to just show and kind of walk through our offering. We have one offering in this category, but it's really it's one of our bread and butter products. It's got great track record, history, customer feedback. Is our Super-Trex 600 volt welding cable. It's UL listed. It's got all the approvals and ratings that are needed for to put in most applications, welding applications. Max conductor temp of 90C. And yeah, we use finely stranded 34 gauge copper conductors. This is going to improve flex life and overall flexibility. And the 100% fabric serve, that is going to also help with that shrink back issue, because it keeps everything tight and almost acts as a reinforcement. And again, playing on that, you have to make sure all the components are working together, and that is a big piece of our construction, is that fabric serve in between the jacket and the copper. So again, we had a ton of success with this cable. We use it's a thermoset elastomer CPE jacket, which is common across a lot of our Super-Trex within that Super-Trex family.
So what's the Amphenol TPC benefit to you? As we mentioned, it's a safer cable, right? One, it helps you keep your production going, and it is helps prevent that downtime and keeps your guys safe for unnecessary arc strikes or potential fire hazards.
Yeah, and if there on our website we have various real examples from the field, so with customer testimonials. One right here, a quote from a Northtown Diesel Shop: "ATPC has greatly reduced downtime and is an important asset to our welding safety program." That's something that we take a lot of pride in, between the product group, our engineers, and marketing, is putting the best product, the safest product out there. I would encourage you, if you find the time, to check out the website, and yeah, those hyperlinks you can find by navigating the website. But it's good. They're good reads, and it really is a testament to the cable's performance, and why it's one of our highest moving products.
One other thing that we do is as you see the burn cam lock, we actually now manufacture our own cam locks. We have a molded 12 series that will mate to any other 1012. We can also make custom assemblies where we will install or basically put the molded end on the cable itself, and the conductor is molded inside the actual cam lock, so it gives it a lot more security and helps prevent shrink back at that area. It's a nice addition to some of the things that we can do for you.
Great. Thank you, Paul and Eddie, for the presentation this morning and now into this afternoon. A lot of insightful information. We've had 2 questions submitted that maybe you guys can take a stab at answering here. First question is, can welding cable contribute to workplace safety violations? Is there any thoughts behind how these cables can impact safety violations in the workspace?
Yeah, that's a great question. There actually is. So there's an OSHA standard. I can't recall the standard number off the top of my head. I think it's in the 1920 something, but anyway, it's under the subpart welding and cutting. So they do. It is an OSHA violation. One of the things that they discussed within this article is, cables in need of repair, or if there's any visual or suspect areas of damaged cable, it should not be used. So they will ding you on those issues, and then especially if there's exposing bare copper is going to be an automatic. The OSHA will crack down on that right away. This is a huge safety issue, and they really do. There's a high focus on exposed copper. So yeah, Tom, that's a great question.
And the last question that was submitted here is more along the lines of how to handle the cables. And the question is, why should weld cables be uncoiled before use?
Oh, yeah. Well, one of the things that happens when the cable's coiled up and it is being used, it creates inductance, which is basically a giant magnet, but it also generates a lot of heat. So if you're running high amperage through that cable and it's in a coil, the heat has nowhere to dissipate. So it becomes a fire hazard. I've seen cables and coils melted together where the jacket just basically ruptured and flames shot out because there's so much heat coming through that cable. So that's another safety hazard of why it should be uncoiled, to allow a much smoother flow of current rather than rolled up and really giving it nowhere to dissipate.
Great. Thank you, Paul and Eddie. Those are very precise answers to the questions there, and appreciate your time. We'll transition here to end the webinar for today. We have the contact information for both Paul and Eddie here in the slide deck, and the slide deck will be distributed to the audience for use. Feel free to reach out to Amphenol TPC when you do have questions about your welding operations, and specifically welding cable. That includes leads, control cable, power cables, etc., with or without connections. We could help you in finding a solution that's right for your application. So again, thanks, Paul and Eddie, and we'll sign off for today.